All right, welcome to Polynomials. This is the first video on polynomials. We are going to be talking about adding and subtracting, polynomials in general, and what a polynomial actually is. And there's a few different kinds of polynomials, and we're going to kind of classify them and talk about a couple other things. So the first type of polynomial is a monomial. Monomial is a single term that's defined by some coefficient times a variable raised to a certain power, where a is a constant, or ax to the nth power, where a is a constant and m is a positive whole number. And the x is really just a variable. It could be any variable, it could be x, y, z, whatever variable you were using. But it is just one term, okay? A polynomial is a monomial or two or more monomials combined together by addition or subtraction, basically more than one term. So a monomial is a polynomial with one term. A binomial is a polynomial that has two terms, okay? And a trinomial is a polynomial with three terms. You could keep going, a quaternomial, a pentanomial, but really everything after trinomials, everything after three terms, is really, we just call it a polynomial, okay? So I have a little chart here that kind of just tells us what are some examples of polynomials. So for my first one here, I have b plus 1, I have 2, it's a binomial really because I have 1, 2 terms. Here it's 4y squared minus 7y plus 2. This is really a trinomial, but it falls under the kind of umbrella of polynomials. And then this is just a polynomial that has 5 terms, and really we just call that a polynomial, even though it could be a pentanomial, which is 5 terms, but we just call it polynomial. Now a monomial only has one term. It's like 14, 8y squared, and negative 9x cubed y to the fifth. Now, even though there's two variables in there, this is still one term because everything's being multiplied with one another. I don't have any like plus and then another variable. Whereas if we take a look at every binomial, I have two terms that are separated by either positive sign or negative sign. And really, we're talking about positive representing addition or negative representing subtraction. And then a trinomial also has 3 terms for all of these, okay? So if we take a look here for our first example, we really need to determine whether it's a monomial, binomial, trinomial, or a polynomial. We need to say more than 3 terms. So I like to kind of break it up if you can. So I have 1 term, 2 terms, 3 terms. This is a trinomial. Now here, I just have 1 term for b, so this is a monomial. Now here I have, let's see, I'll do a different color. I have 1, 2, 3, 4, 5, which falls under the polynomial category. Then I have d, which is 1, 2. So this is a binomial because it's 2. And then e is just a monomial again because it's just 1 term. So that's kind of the first categorization, whether it's a monomial, binomial, trinomial, or polynomial. The next thing that we usually talk about with polynomials is the degree of a polynomial. And when we're talking about the degree of a term is the sum of the exponents of the variables. And the degree of a constant is 0. So basically the degree of the polynomial is the highest degree in all of its terms. So if we take a look at this list of polynomials, or monomials, okay? So for 14, that's a constant, the degree is 0. Now if we take a look at 8y squared, the exponent is what gives us the degree, which is 2. Here, if we take a look at negative 9x cubed y to the fifth, we're taking that 3 and that 5, we add them together and we get 8. So that's the degree. And then here, whenever we do not have an exponent clearly listed, we assume that the degree is 1. Okay, so that is monomials. For binomials and really anything else, we're going to take a look at the degree in each term, and we're going to kind of just take the largest one. So here the degree is 1 and a constant is 0, so which one is the largest? 0 or 1? The 1 wins out, so the degree of the polynomial is 1. Here the degree of the first term is 2, the degree of the second term is 1, 2 is larger than 1, so the degree is 2. Now here I have x squared, y squared, so 2 plus 2 is 4, which is how I got that. And then the degree of a constant is 0, so which one's larger? 4 or 0? 4, so that is the degree of the polynomial. So I have 3n cubed, 9n squared. The degree of the first term is 3. The degree of the second term is 2. 3 is larger than 2, so the degree of the binomial is 3. And then we could do the same thing. We could keep going, essentially, for trinomials and polynomials. We just have more terms that we need to take into consideration, and they may not all be in order necessarily. So we'll do a quick little example here, and then we're going to just go ahead and start adding and subtracting. So find the degree of the following polynomials. So for A, we don't have, it's a monomial because we have one term, and when we don't have a exponent clearly listed, we assume that it is a 1. So therefore, the degree of A is going to be degree 1. Now, if we take a look at B, the degree of the first term is 3, the degree of the second term is going to be 1, and the degree of the third term is really 0, meaning to say, which one's larger, 3, 1, or 0? The answer is 3, so that would be degree 3. For C, it's a monomial, but it's a constant. Therefore, the degree is 0. Now, D is a trinomial. I have 1, 2, 3 terms. Okay, for the first term, my exponent is 2, so the degree is 2. My exponent is 1, so the degree is 1 for the second term. And for my constant, my degree is 0. So which one's larger, 2, 1, or 0? The answer is 2. For the last one, we have a binomial. And then here, keep in mind that the x is 1, the y is 2, so the degree here is 3. And the degree for my second term is 1. So which one's larger, 3 or 1? The answer is 3, so that is a degree 3. Okay? I could give you some more examples, but we really just need to move on. This is just how we label certain polynomials, okay, and how we are able to categorize them with degrees. It's how we help describe polynomials. If it's a monomial, binomial, trinomial, and then what degree it is. The meat of this lesson is really just adding and subtracting. Okay, and not necessarily monomials. We're talking about all polynomials. In this case, the first example is adding two monomials together. And what you're looking for is really if the variables are the same and the exponents are the same. Okay, meaning you say, are they the same degree? And the answer in this case is yes, because I have a y squared and a y squared in the second term. They are like terms, so we would just add the coefficients together. 25 plus 15 is 40, and so that would be 40y squared. Okay. For the second example, I have p and p. Both are to the first power. So I can go ahead and add, well, subtract these two, but a negative and a negative is a positive. So really I'm doing 16p plus 7p. Okay, so 16 plus 7 is going to be 23p. And that would be the answer there. Next example. We have c squared, d squared, and c squared. Well, the only ones I can really add are the ones that have the same variable with the same exponent. And I'm going to add the coefficients, the numbers in front. And since I don't have a number in front here, we assume the number is 1. So I'm going to add my two c squared terms together. 1 minus 6 is negative 5, c squared, and then we just have to leave the 7d squared by itself. and that would really be the answer. Okay, next one, we need to start kind of taking a look here. I have u squared v. I don't have another u squared v here. I have a u squared and then I have a v squared. Well, guess what? None of these are like terms, so I actually cannot do anything with this. That would be the answer. I cannot add or subtract anything. And that's okay too. We don't want to start coming up with new creative math. Now let's take a look at the next one. I am going to start highlighting some things just to keep us honest. We are adding two trinomials together, but since we're adding, it really doesn't matter. If we had a negative here, then it would matter. We'd have to distribute the negative first, and then we could go ahead and try and figure out our like terms. So I have a y squared, I have a y term and a y term, and I have a constant and a constant. So I'm going to add my two yellows together. So I have 5y squared plus 3y squared is 8y squared. I have negative 3y plus a negative 4y. That's going to be a negative 7y. And then I have 15 plus a negative 11, and that is going to give me a positive 4. And that is the simplification. That's the sum of two trinomials. All right. Now let's take a look at the next example. Notice I have a negative, which means to say I need to distribute it to the whole thing that's in the parentheses. It happens to be a binomial with degree of 2. Okay, because 2 is the largest exponent. So I'm going to keep the first term the same. So 9w squared minus 7w plus 5. And then that becomes negative 2w squared plus 4. So now I can go ahead and start happy highlighting. Do I have anything with y squareds? Why, yes, I do. I have 9y squared and I have negative 2y, or 2w squared. Do I have another w term? Well, I don't, but I do have constants, so that's what I'm going to add as well. So here we go. Let us do 9w squared minus 2w squared, which is 7w squared. I'm going to keep the 7w, and then I'm going to add my constants together, which is 9. And that would be the solution for this next example. Okay. So, next example, it says subtract this trinomial from this second trinomial, which means to say, actually, this is the trinomial that goes first. C squared minus 5c plus 3, and we're subtracting the c squared minus 4c plus 7. Now keep in mind you do need parentheses because we're subtracting the whole quantity of c squared minus 4c plus 7. So we need to distribute that negative. So I have 7c squared minus 5c plus 3 minus c squared plus 4c minus 7. Okay, so now let's go do some happy highlighting. I have two c squared terms, I have two c terms, and I have one constant term. So now let's go ahead and combine my like terms. 7c squared minus c squared is going to equal 6c squared. Then I'm going to do negative 5c plus 4c, and that's a negative c. And then I have 3 minus 7 is a negative 4. And that is that next example. I am going to skip that next one. Actually, I'm going to go straight to the next one if I have some time here. And first things first, you need to make sure you distribute. So I have a cubed minus a squared b minus ab squared minus b cubed plus a squared b plus ab squared. And I wanted to make sure I did this because now we're going to have a happy highlighting situation. Okay? And